Okay, I have put together a few work problems to go into the algebra section, Kickstart, and I've got three problems that are pretty generic, and you can use them with other type problems, but the three type problems are pretty basic as far as algebra goes. First of all, let me just talk about what kind of work problems they are. And they're called work problems because they want to know how much work is done, or sometimes you might see distance also, or rate times time. Distance equals rate times time, or R is equal to D over T, or T is equal to D over R. Now you might want to make a note about these because these are three formulas that are used. You don't plug and chug like you did in formulas like D is equal to 5 and T is equal to 2. It's more of an algebraic formula that you plug into. Work problems, cutting the grass. Jane takes 3 hours to cut the grass. Joe takes 2 hours to cut the grass. How much does it take both of them to cut the grass? How much time does it take both of them cutting the grass? Walking home. Takes John 2 hours to walk home. It takes Jane an hour and a half to walk home. How long does it take? How many miles is it from their home or from school or whatever the case may be? Planes, boats. Planes usually have a headwind and a tailwind. Boats usually have upstream and downstream. So these are just some of the examples that you're going to be using, or some of the problems that you're going to see with the work problems / distance problems. So let's go ahead and look at one. It says Mike can tile a room in 14 hours. Joe and Mike can tile a room together in 9 hours. How fast can Joe tile a room alone? So you got the work problem, so I'm just going to put distance equals rate times time. R is equal to D over T, and T is equal to D over R. And again, those are just solving for a variable. We know that it takes both of them 14 hours. I'm sorry, it takes one of them 14 hours and the other one together means equals so that would be a 1 over 9. Now the actual job is, you could say, the distance, okay? So that would be 1 over 9. In 1 hour, it takes them 1/9 of the job is done. That's basically what you're saying. And you got Joe, Mike, and then you got Joe, and they work together to do it in 9 hours. So that would be 1 over 14 plus 1 over whatever time it takes Joe to do it. And I'm going to put a little J here. Now you don't have to put the T sub J, but I'm just letting you know that this is Joe's time. How long it takes Joe to actually tile a room. You don't have to put that, but that's what we're looking for. You can just put an X there if you want to. Alright, so we need to multiply through by the common denominator. The common denominator of 9, 14, and x is 14 times 9 times x. So you're going to distribute that. And I'll put a baby step in there for you. 14 times 9 times x over 1. 14 times 9 times x over 1. 14 times 9 times x over 1. I distributed that. 1 over 14 plus 1 over x, we can change that to an x, equals 1 over 9. And of course you see that the things cancel, 14 cancels, x cancels, and 9 cancels. And that leaves us with 9x plus 14, that's, I want to say it's 126, is equal to 14x. Now I want to keep the variable positive. So I'm going to move the smallest bucket, and the 9 is the smallest. So that would be a 9x. So that would be 5x is equal to 126. And 5 will go into 125 25 times. So that would be 25, and there's 1 left over, 1/5, which is equal to 10. So 2/10, which is 25.2. So it takes both Mike and, it takes Joe 25 hours to tile a room. Now the only difference you're going to see with these type problems is you're going to see this right here being the unknown sometimes. And it'll say, this is a different problem. It's going to say Mike can do the room in 14 hours, Joe can do the room in 20 hours. How fast can Joe and Mike tile the room? So most of the time you're going to see this part be 1 over x. And then of course that would be 1 over 14 plus 1 over 20 is equal to 1 over x. So you might want to make up a couple of problems and see what you can come out with. Now of course you check it by taking 25.2 and plugging it in right here and see if you get 1/9 on both sides. Okay, so that's one type of problem. Mowing the grass, baking a cake, fixing a wedding cake, tiling a room, you know, different examples. Walking home, different examples, or different types of questions with this type of question. Alright? The second type question is the problem about the boat. And I think I got one here. Sorry, I can't blow it up. I'll blow it up and let you look at it. A boat goes 20 miles against the current and 60 miles against the current. Against 60 miles with the current, and it takes the same time. The current is 4 miles per hour. The current of the water is 4 miles per hour. What is the speed of the boat in still water? Most of the time, this is the type problem you're going to see. They can change it a little bit. They can make one, and then you find the speed of the current. But the problem is done the same type. Of course, distance equals rate times time. T is equal to D over R, and R is equal to D over T. this type problem, planes, trains, boats, mostly with boats and planes, because of the upstream and downstream, or the headwind or the tailwind. You can draw yourself a picture, but I will tell you this: if you've got a current of a river going this way, and you've got a current of a river going this way, if you set these equal to each other, what do the currents do? They cancel each other out, and that's where the still water comes in. So the still water basically tells you that you're going to be setting them equal to each other. Okay, so that's a little trick that you might want to make a note of. Another thing you might want to make a note of is the same time. The same time tells you that they're traveling the same distance in the same time. Okay, not a big deal, but it's something that you need to make a note of. Most of the time the question will say that, the same time, in the same time that it travels 60 miles upstream. And the still water is pretty common also. And the plane will be a headwind or a tailwind. This is upstream is against, and downstream is with the current is downstream. Headwind is against, tailwind is with the plane. So both the planes, trains, and are going to be set up with a little chart. Distance equals rate times time, and put a little upstream and downstream here. The reason I put that negative and positive, that'll affect the rate. The negative will go with the upstream and the positive will go with the downstream, or the headwind. I want to put that headwind and tailwind. Distance is 20 and 60, and that's given right there. The rate, well, the speed of the boat minus the current, and the speed of the boat plus the current. Now you can put an X right here. Most people put X, but for instructional purposes I'm putting an S because that's the speed of the boat. Technically you could put an SB, speed of the boat. And then T is equal to T, because basically you're trying to find the time, so you're setting them equal to each other at the same time, so you're just going to set these equal to each other, or you could write it out. T is equal to D over R, so this T is equal to 20 over S minus 4, and this T, and that's upstream, and this is downstream, is 60 over S plus 4. Now, in still water means that the currents are canceling each other out. That's what this means, still water. Still water means that you're going to set this guy equal to this guy, or this guy is going to be equal to this guy. This guy is equal to this guy. They cancel each other out. So that's going to be 20 over S minus 4 is equal to 60 over S plus 4. And cross multiply 60 times S minus 4, 60 times S minus 4 is equal to 20 times S plus 4. Now we're going to take that to another page. And that's going to be 60s minus 240 is equal to 20s plus 80. And the smaller bucket is the 20s, so it comes over, makes 40s. Take this over, equal to 320. Divide by 40, divide by 40. S is equal to 32 divided by 4 is 8. So the boat is going 8 miles per hour in still water. Okay. Now the only variation in this problem pretty much is they're going to ask you for the current, and they give you the speed of the boat. And they give you the speed of the boat, then it'd be 4 minus the current, 4 minus x, and 4 plus x. If they gave you the speed is equal to 4 miles, speed of the boat is equal to 4 miles per hour, then it would be 4 minus the current, 4 plus the current, and then you'd solve for the current. Okay. So once you learn these 3 types of problems, you can pretty much do any of the work problems. You just got to know where to put the given information. The next problem uses a little bit more algebra, and it's the planes, or one like the planes type. It may be boats also. But it says 2 planes fly the same distance. Again, there's the same distance of 600 miles. So that means when you set up your little chart, the distance is going to be 600 and 600. So that's a very important word right here. One plane is 50 miles per hour faster. The other plane arrives 2 hours later because it's slower. So you got a fast plane and you got a slow plane. So distance equals rate times time. R is equal to D over T, and T is equal to D over R. We're going to set up our chart. Distance equals rate times time. We got a fast plane, and we got a slow plane. Distance is 600 miles. The fast plane is going at a rate, and it's going at a certain t. But the slow plane is going r minus 50 and t plus 2. You got to add on 2 hours to the slow plane. So 600 is equal to r times t, and 600 is equal to r minus 50 and t plus 2. Now this is the solving systems of equation. Like I said, it's a little bit more algebra, a little more in-depth algebra. So we're going to use substitution. It'd be the easiest to use because it would just be easier. So solve for t or r. I solve for t. So t is equal to 600 over r. So I'm going to take that 600 over r and I'm going to plug it in for that t right there. And that's going to give me 600 is equal to r minus 50 600 over r plus 2. Now it may look intimidating, but it's really not, because all you need to do is use your FOIL method. And when you use the FOIL method, that fraction is going to cancel out. I'm going to put little parentheses around here so that way you know that I plugged it in. And when you use the FOIL method, you're going to get 600 is equal to, the r's cancel when you multiply the first, that would be 600 plus 2r, r times 2 is 2r, minus 50 times 600 is 30,000 over r, and then negative 50 plus 2 is negative 100. So use your FOIL method to go from here to here. Clear the fraction, multiply through by r, you get 600r is equal to 600r plus 2r squared, the r's cancel, minus 30,000 minus 100r. The 600r's cancel. Now you're left with a quadratic. And you can factor out a 2, so 0 is equal to r squared minus 50r minus 15,000. That's the quadratic, and you can use completing the square, or you can use the quadratic formula. I would use completing the square, because completing the square, you don't have to depend on the calculator. And when you use completing the square, you basically get this. Here's our problem right here, and I just added 1500 on the other side. I brought everything over, so here's my blank, here's my blank. Half of 50 is 25, 25 squared is 625. So that gives us shortcut number 2 right here. Which gives us this. And then take the square root of 15,625, and that's positive or negative 125. Distance or rate, speed cannot be negative, so the negative is done away with. So you got 125 plus 25 is 150. So the fast plane is going 150, and then the slower plane is 150 minus 50, which is 100. Now again, you've got 3 separate type problems. You've got the cutting the grass problem, baking a cake problem, tiling a room problem. That problem is done by 1 over the time plus 1 over the time is equal to 1 over the time. Right there. Okay. The second type problem is the problem where a plane or a boat is going upstream, downstream, or going headwind, tailwind. And that's when you have to use a chart. And then the last type problem is the same as the second, only this time you have to actually go into a little bit more algebra after you get the 2 rates, or the 2 distance equals rate times time, distance equals rate times time. Distance equals rate times time Distance equals rate times time. You got two equations, two unknowns. So it is solvable. And that's using solving systems of equations. So that is a little bit on work, and I hope that helps.